Welcome to the part 3 of this video series. In this part of the video, we will look at some more questions. These are all real exam questions, and the chances of getting similar or same questions in exam is high. Please refer to the parts 1 and 2 of this video series for questions 1 through 30. Please subscribe to my channel and like my videos. This keeps me motivated to put in some more content similar to these videos. Now let's jump to the questions. Now this question says that you have a transactional application which is storing its data in Azure SQL managed instance, and you should implement a read-only database replica. When should you use a read-only replica? Now let's scan the options from option D to option A. Option D suggests you need to improve the recovery point objective. Now let's also look at option C, which says you need to implement a high availability in the event of a regional outage. So both these options, C and D, are related to disaster recovery. And whenever you use a read replica, it is never for disaster. You have something called backups and snapshots to address the disaster requirements. Now let's look at option B. It says you need to audit the transactional application. So we do not use a read replica to audit a transactional application. A transactional application is residing within a database and some set of tools or for the front end and the middle layer. But you do not create a read replica for maintaining the audits or to use an audit of a transactional application. You do not do that. Now option A looks correct because whenever you need to generate reports, so what you do is like the question says, this is a transactional application. So transactional applications has lots and lots of rights. Now you do not want to disturb those rights. You do not want those rights to be slower, because then that will have a very bad user satisfaction. So what you do is cut the read loads, put it somewhere else. So the read replica is the place where you do that. Create a read replica database, put the reports which is read heavy, put that part of the application which is read heavy on that read replica, so that the transactional workloads are left isolated and they do not impact performance. So here goes our answer. We lock option A is our answer. Now let's look at this question. So this is a straightforward question where you do not have a lot of logic. This is something which is a feature of Cosmos DB. Cosmos DB has gives you options to set the throughputs at a database level and at the container level. The containers are inside the database, so you have options to set the throughput for each container, or you can set it at the database level. And if you set it at the database level, that throughput is shared across containers. These are our two answers. There is no logic to this. These are features of Cosmos DB. Now let's look at this question. So you have a Cosmos DB which is using a SQL API, and then you want to configure settings at the container level. So which settings are available at the container level? They want two options, two answers. So the two answers here would be throughput and the partition key. This is something which is a feature available at a container level. You can define partitions, partition key, logical partitions at the container level. So if you have a data set which is belonging to, say, a food group, and there are different food groups like beef products, chicken products, vegetable products, etc. So you can define those logical partitions at the container level. So options A and C will be our answers. Let's move to the next question. This is a bit tricky. I would not say a lot tricky, but a bit tricky. What it says is which solution supports RBAC at the file and folder level. So when we talk about files and folders, we are talking about hierarchical structures. So always remember, whenever there is a question which has hierarchical structure, link to storage, it is always data lake storage, because data lake storage has a hierarchical structure. Blob storage doesn't have that. Queue storage is a very different animal. It's used for storing messages, and disk storage is a block storage. So this is our answer. Let's look at this question. So here the question is talking about storage for 7 years, and they say that the retrieval time of the data is not important. So even if it takes 5 hours, even if it take 2 hours, or if it take 10 minutes, or if it take 10 hours, they don't care. The retrieval time of the data is not important. So in this case, it clearly is a good uh, proposition for an archive data storage. The reason for that is, hot is something where you need a very fast retrieval time, and cool is slightly lower than hot. So you have some leisure of time. But for archive, this is something which you have to store for a longer period of time, and you should use archive because that is how you will minimize your storage cost. If you don't want to minimize your storage cost, you can use cool and hot and etc. But the question is asking about minimizing the storage costs. So among the three options, archive is the answer. Hot is the costliest option among these three. Now let's look at the next question. So here the question is talking about a non-relational data store, and hence columnar can be striked out because it's a relational data store. And then this question is talking about JSON files and flexible schema. So both graph and time series, they do not support flexible schemas. So document is the only database which supports flexible schemas and data stored as JSON files. Hence we lock option A as our answer. Now let's look at the next question. So the question is saying, do you have a shared folder on a Windows server and you want to move it to an Azure storage? So which storage to use? So since we are talking about shared folders on a Windows server, so these are mostly files. So file should be our option here. Now blob, queue, and table, these are object stores. So for example, Azure blob, Azure queue, these are object stores. We need to store it in a file. So file is similar to uh, Amazon EFS. Now let's look at the next question. Now the requirement is to hold the session data for a website, and these are the attributes of those data sets that needs to be added to the shopping cart. So the ask is, which data store will provide the lowest latency? Let's decode the options. Option B, graph database will not work here. It is used in cases where you have relationships to be set up between the data elements and you have nodes structure. For example, you go to amazon.com and you try to shop for a product, and the moment you buy that product, it also gives you recommendations that people who bought this product also chose to buy these other products. So that is happening because the data is stored in a relationship uh, in terms of nodes and etc, which is in a graph database, and that's why it is able to provide you those kind of suggestions. So graph is not applicable here because the question is not asking for a similar requirement. So option D is useful if you have schemaless databases and the requirement has flexibility about the number of fields being entered. So here we do not have that flexibility. There is a straight cut requirement that the data will include notifications, personalization, attributes, and products. So we are very clear of the number of fields that are needed on these databases. So we'll strike off D, and option A, which is a key value store. It is useful for simple read-write operations, something like a Cosmos DB. It is not suited if you want to search by value. It is good for simple lookups. So we will zero in on columnar database. Columnar databases are designed for heavy reads and provide low latency during the reads. So as you see here, the session data will be stored for a website. It is important that whenever the user logs in next time, the session data is available immediately with lowest latency. Hence, we will lock our answer as option C and move forward. Let's see the next question. So here we need to spot the streaming workload. Let's scan through the options. Option A, sending transactions or the older transactions to an archive. This is an example of archiving, which usually operates in a batch window. Streaming is related to real-time streaming. Streaming doesn't operate in batches. It is always real-time. So option A is not a case for a real-time because you can archive it anytime, any day, and you do not have a requirement of real-time archiving. Let's say option B, which is saying sending daily transactions. So daily transaction is a batch. It is not a real-time transaction. And daily transaction, like for example, you collect all the data from the point of sales for something like Marks and Spencers or Walmart. You collect all the data, and at the end of the day, you send those transactions in a batch to the head office databases or etc. That's not real time. That's not an example of streaming workloads. Sending cloud infrastructure metadata every 30 minutes. When you're sending a metadata, it is not having a lot of changes, and you're sending it every 30 minutes. It's not real time. So what you're doing is you're basically collecting those data sets and waiting for a trigger point of, say, a schedule, and every 30 minutes you're sending that data point. So this is not an example of real time. Option C is an example of real time because you're sending telemetry data from edge devices. So you're sending it real time. Telemetry data is always real time. So now you may ask, here they have not mentioned on daily basis or monthly basis, etc. The time is not mentioned, but always remember telemetry data is real time. There is no use of sending the telemetry data after a couple of days because that data point will not be useful to make decisions which is real time. For example, you have sensors on your gas pipes, and if there is a gas leak and the telemetry data is already sending that leaked data, and you don't take action or your data doesn't get transformed and sent across for analysis purpose or for real-time analysis, then you lose that time and an explosion occurs. So hence option C should be locked. This is the right answer. So we are towards the end of this video. Please subscribe my channel and like my videos. Please drop in your comments if you have any constructive feedback. We'll see you in the part 4 of this video series.